Then in the C part, they are asking you to compare the powers. Now, to calculate the power, we can use any one of the three equations. P is equal, there are three equations as you know. Power is equal to VI, power is equal to I squared R, power is equal to V squared by R. So you could use any one of these three. So they are asking you to compare the power dissipated by the two lamps, the total power dissipated by the two lamps, to the total power dissipated by the battery. Now for the battery, it's immediately obvious that it's better to use an equation without resistance, because otherwise we have to find the resultant of these all four resistors, two resistors and the resistances of the lamps. That's difficult. So it's better to use power is equal to VI for the entire, to find the total power dissipated by the battery, and we can use the same thing for the battery as well, right? So we have two resistors of value 30 ohms each, and we have two resistors of value 30 ohms each. So you can use the other two equations, but they have all the squares and everything. So I would still prefer using power is equal to VI for the two resistors, since it's easier to for the total voltage drop is 12 volts and the total current is 0.2 amperes through this branch. So we can still use power is equal to VI for this branch as well. The total voltage drop 12, total current in through this branch is 0.2, so 12 times 0.2, that is the power drop here. Then the total power drop would be 12 times 0.5. So if I write that, so the power drop of the lamps, the 12 volts times the 0.2 amps divided by the total power drop, that would be 12 volts times 0.5, the total current. So that would give you a ratio of 0.44. That will give you a ratio of 0.4. It would give you a ratio of 0.4. Then in the D part, they are asking you that what would happen if the resistor R is now replaced by a resistor of lower resistance. So when you replace this with a lower resistance, the resultant of these two resistors would decrease, and in a parallel combination the resultant resistance will also reduce when this one reduces. So overall the total resistance will decrease. When you decrease the resistance of this one, the total resultant resistance between these 2 points will also decrease, but you still have the same EMF or terminal potential difference since there is no internal resistance. So the V remains the same, but the R is reducing. That means I would increase. V is equal to IR. But when current increases, what would happen now? Here we were using for, like, this is the potential difference due to the bulb. That depends on the EMF of the battery and the total current. So that when the total current increases, this factor, the denominator, is going to increase. If you consider the numerator, it's quite difficult to use P is equal to VI and discuss that, because now we don't know what will be the distribution of current. For 0.5 it is 0.2, 0.3, but now for the new current value, which is greater than 0.5, that we know, but we don't know how it's going to be distributed. But if so, we would take an equation which doesn't depend on current, So we will take this one. And if you consider for that equation, now the voltage drop between this point and this point is still 12 volts. Even if you change this resistance, the voltage drop through this branch will not change. And the total resistance would be the sum of the resistance of the two lamps, and that is also not changing, which means that the power dissipated by the two lamps will not change. So the numerator value would remain the same, it would remain constant, but the denominator is increasing, so the ratio would decrease. So what is happening? The total resistance decreases, hence the total current increases, but the voltage across the two lamps and the two lamps remains the same, hence the power dissipated by the lamps remains constant, but the power dissipated by the battery increases, hence the ratio would decrease. Basically, this question has all the fundamental ideas which you would be using for the remaining question, the question number 2, 3 and 4. You can see how it is again and again repeated. So understand this question totally.